In this lecture, we're going to see how we can set up function overloads based on pointer parameters. And here is a simple example which is going to take advantage of that. The big idea here being pointers to different types in C++ are treated as different types. So if we look to the right here, we have two functions which have the same name. So these are two overloads for the same function here. And they are valid C++ overloads. And the reason is the parameter list is different somehow. The first parameter list here is going to take the first parameter to be a double pointer. And the second function here is going to take an int pointer. And pointers to different types are different types. So these are going to be valid overloads in your C++ program. And this is going to be useful because, for example, if you are interested in computing the maximum in an array, you don't really have to worry about the types that are stored in that array. You can find the maximum for an array containing integers. You can find the maximum for an array containing doubles, and you can call these functions directly. And the compiler is going to choose whichever function makes sense based on the arguments that you pass in here. This is how function overloads can really be useful for your application. And if you look at the bodies of the function, they really are the same. The only difference is that we really are working on a double type in this first guy, and we are working on an int type in this second function here. The logic is really the same. I realize this is going to be duplicating code, and duplicating code is something you should avoid in C++. But we are learning, and I am trying to show you that sometimes function overloads can be useful. And if it makes sense for your application, please go ahead and take advantage of this. Here is a simple slide showing something you should really be careful about. These three functions are equivalent. And if you try to set them up in your C++ file, you're going to get a compiler error. And they are equivalent because they really do the same. The first one is going to take an int pointer, and we have seen that int pointer and an array of ints, they really are the same thing. The name of the array can be treated like a pointer to the first element of the array, so numbers here is really int pointer. And the third function here is really the same array. We are just specifying the size of this array, so this can also be treated as an int pointer. So the compiler is going to treat these three functions as the same type, and if you try to set them up as is, you're going to get a compiler error. Now that you have an idea about this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is overloading with pointer parameters. We're going to grab our template files here, and we're going to put them in place. And we are going to open this guy in Visual Studio Code. Let's drag and drop here. We have our main function. We're going to clean it up a little bit. We're going to remove what we don't need here, close the left pane. And we are going to put in our first function, which is called max. The parameters are double pointer and size t to give the size of this array that we can pass in here. And we're going to compute the maximum in this array. This is nothing you haven't seen before. We're going to set up a variable which is going to contain our maximum. We're going to be looping around finding whichever number is greater than the maximum here. And if we find it, we're going to set that as our maximum. By the time the loop here is going to be done, we will have the maximum stored in our variable here, and we're going to return it. Okay, now that we have this function, what we really want to see is that we can set up an overload of it based on our pointer type here. So pointers to different types are different types. So if we change our type here, but before I change that, let's try and build and show you that we're going to have an error if we build this program. We're going to get a linker error because we're going to have two functions that do the same thing. We're going to have a redefinition of some function here, and this is violating the one definition rule. So we can't have two completely identical definitions for the same functions in our C++ program. This is violating that rule here. So we are not allowed to do something like this. But we can make these two functions different because we want to be able to compute the maximum in two different arrays that contain either double or int. And this is going to give us the flexibility to do that. At least in the main function here, we don't have to worry about what is stored in the array to be able to compute the maximum. So we're going to change the second guy here to be int. It's going to be working on an int array. The first one is double, the second one is int. And we're going to set up an int variable which is going to contain our maximum. And because this array contains int, we're going to return int here. Once we do this, the parameters are going to be different because double pointer and int pointer are different. So these are going to be legal overloads in C++. If we try to build again, the compiler error is going to go away because this is legal C++ code. The build is successful. Okay, now that we have this, we can head over in the main function here and set up two arrays. We're going to set up a doubles array and an int array. The doubles array is going to contain double data. The int array is going to contain integers. If we go down and say auto result and say max, and we pass in doubles, for example, and we pass in std size, we can do that, doubles. This is going to call the doubles overload. And let's say that, we're going to see that called here. So we're going to go inside this function and say std cout doubles overload called. You can really put in this std cout statements to see your functions called to really make sure you understand what is happening. Okay, we're going to also grab this and put that in our int overload. Let's do that. And we're going to paste that in and say int overload called. We're going to be sure which function is called here. So now that we have this in place, we can compile and run our program, and we're going to see which overload was called. The build is good. As you see down here, we can clear and set up a terminal, and we can clear again here and run Rooster. You're going to see that doubles overload was called because what we are passing in here is an array of doubles. And this is going to call this overload here because it can treat the first parameter, which is an array, as a pointer to double. This is going to be called, and it is going to compute our maximum. And if we print result here, we should see the maximum in this doubles array printed, which should be 30 here. Okay, let's build again. We can clear and run Rooster. Result is 30. This is the maximum in our doubles array. And again, this is proof that the double overload of this function is being called. I should say the double pointer version. If we change our parameter to the int array, let's do that. We're going to say ints, and we're going to say ints here. Let's say ints here. This is going to select this overload, which takes int pointer, and it's going to compute the maximum, and the maximum in this int array is going to be returned, which happens to be the 8 here, if I am right. So let's see what we get when we build and run this program. We're going to build with GCC. The build is good. As you can see down here, we can clear and run Rooster. Int overload called, and the maximum is 8, as you see down here. Okay, hopefully this proves to you that pointers to different types are treated as different types. And we can use them to make two overloads of the same function different. And again, if these kinds of things make sense for whatever application you are designing, make sure to use these facilities to your advantage. The next thing I want you to try out before I let you go is different syntaxes that can really throw you off and make you think they are different. For example, here we have an int numbers array without a size, and we have another array with a size here. And the compiler is going to think that these two functions are the same. We can actually put in another, which is going to take an int pointer. We can copy this and put that down here. And we're going to change the first parameter here to be int pointer numbers. And if we try to build this program, we're going to get a compiler error because we are redefining the same function multiple times. These three functions here, the first that takes an array without a size, the second that takes an array with a size, and the third here, which takes an int pointer, are going to be basically the same. And the compiler is going to freak out if it sees all these guys in your program here. Let's try and build. We're going to use GCC, and we're going to see a compiler error here, and it is going to be saying redefinition of int max, and we have basically different versions of the same function. The reason is an array is really the same as an int pointer. And we have an array here without a size, we have an array here with a size, and we have an int pointer here. So the compiler is going to think that these three functions are like the same. If you want to use any of these syntaxes here, you will have to take out the others. For example, we can take out the last two here. Let's remove them. And if we build now, our program is going to compile because we have one definition for this function here. Let's build again. If we go down here, you see that the build is failing because we had an int pointer version of this function here. So we can't set this up again. Sorry, I had forgotten that we had this overload in, but the message is don't set up functions like this or you're going to have compiler errors that are really hard to debug. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to see how we can overload with reference parameters. Go ahead and finish up here and meet me there.